So question 93, some functions. Pay attention because I've got some detailed explaining to do for this one. So the first thing I want to do is, as quite often is the case, draw some pictures. So what I'm going to do is, for f of x, I'm going to complete the square on f of x. So that gives me this form for f of x. So this is a transformation of the graph of y equals x squared. So if y equals x squared looks like that, then this x minus 2 squared translates that 2 units in that direction, and the plus 5 translates it 5 units in that direction. So the vertex goes to the position 2, 5. So I can now sketch f of x, and that's what f of x looks like. So the range of f of x is the set of values of y, or f of x, and so the values of y, the smallest value is 5 here, and then we get any values greater than or equal to 5. So the range of f of x is f of x, or y, greater than or equal to 5. Okay, so let's try to do something similar for g of x. With g of x, what I'm going to do is find out firstly where g of x crosses the x-axis. And what I've done there is simply to use the equation solver in my calculator, and that's the quickest way to do it. There are other ways, but that's a nice, neat way of solving the equation to find out where g of x cuts the x-axis. And I also would like to know where the turning points are, so I differentiate and get a nice factorizable expression for g dashed x, and when I set that equal to 0, I find the x values where the turning points are. Minus 5 and minus a third. So I can now set about sketching g of x. I've got turning points here at minus 5 and minus a third, but the graph cuts the x-axis at minus 7.25, minus 1.11 and plus 5. So it's looking a bit like that, something like that. But we need to remember that g of x is only defined for a set of values between minus 3 and 3. So there's a picture, slightly neater picture of my supposed sketch of g of x. But minus 3 is about there and 3 is about there. So it's only this part of the curve which is g of x. So here's a neater version of that now. Okay, so that's what g of x looks like. And we want to know what the range of g is. So the range, this is the smallest value of y up to the highest value of y. So the range is these values of y here. So that means that g of x, if we look at the figures at minus 3, g of x is 27. At minus a third, g of x is minus 103 over 27. And when x is 3, g of 3 is 111. So we've got 27 here on the y-axis, 111 here on the y-axis, and minus 103 over 27 there on the y-axis. So that tells us that the range of g is any value which is greater than or equal to this, but less than this, because x is less than 3, so g of x would be less than 111. So the range of g is this. Okay, so the final part of the question is to find the set of values for which both f and g are decreasing functions. So for f first, f of x is decreasing on this part of its function. So any value of x less than 2 or less than or equal to 2 would be a decreasing function. So that's when f is decreasing. G is decreasing, however, from this value, -3, up to the value where the vertex is, which is -103 over 27. So g of x is decreasing between those values. And I've got a less than here and a less than or equal to here, because decreasing is also defined as being equal to the coordinate of the vertex. So finally, I can write down the answer to the last part is the set of values of x that satisfy both this inequality and that inequality, and that is that set of values of x there. So quite a tricky question, lots of detail to take care of there, but that's how I answered it.